Both NASA's Hubble Space Telescope and the European Space Agency's JUICE mission revealed new images of the anomalous interstellar Comet 3 I/Atlas yesterday, offering scientists and astronomy enthusiasts a fresh glimpse of this mysterious visitor from beyond our solar system. While the released images are far from the high-resolution clarity that researchers typically seek, they nonetheless represent a significant milestone in the ongoing observation of the exocomet, which has captured global attention since its discovery. As the world awaits its closest flyby near Earth on December 19th, astronomers are scrutinizing every available image and dataset to uncover clues about its origins, structure, and behavior. The anticipation surrounding 3I/Atlas is further fueled by its unusual characteristics, which distinguish it from ordinary comets within our solar system, and by the fact that interstellar objects like it remain exceedingly rare. The European Space Agency's JUICE Jupiter Icy Moons Explorer probe, which is primarily en route to study the icy moons of Jupiter, played a pivotal role in capturing the most recent images of 3I/Atlas. In November, as the comet made its closest approach within the probe's observation range, JUICE utilized its suite of 5 scientific instruments, including the Janus optical camera, to observe the comet. Although JUICE was not specifically designed for high-resolution comet imaging, it nonetheless succeeded in capturing a grainy but informative snapshot of the exocomet. ESA scientists emphasize that these images provide crucial information, even if they lack the fine detail one might expect from missions dedicated solely to comet observation. The data collected by JUICE is expected to arrive on Earth in February, giving researchers ample material to study the comet's physical and chemical properties in greater depth. The released image from ESA reveals the glowing halo surrounding the comet, known as its coma, which forms as the comet's ices sublimate when exposed to solar radiation. Beyond the coma, scientists were able to discern hints of the comet's 2 distinct tails. The primary plasma tail, formed from electrically charged gas pushed away by the solar wind, stretches outward in the top section of the frame, while a fainter dust tail, composed of tiny solid particles released from the comet's nucleus, extends toward the lower left. These 2 tails, though faint in the JUICE images, are key indicators of the comet's composition and activity, allowing astronomers to study how interstellar material interacts with solar radiation and the magnetic environment of the solar system. Observing the differences between the plasma and dust tails provides insight into the behavior of volatile and solid components within the comet, which in turn helps scientists understand its origin and trajectory. In tandem with ESA's efforts, NASA released new imagery captured by the Hubble Space Telescope, one of the most powerful and reliable instruments for space observation. On November 30th, Hubble's Wide Field Camera 3 captured a snapshot of 3I/Atlas from a distance of approximately 286 million kilometers from Earth. While the Hubble images are somewhat limited by the distance and small size of the comet, they nonetheless offer a valuable perspective on the comet's structure, brightness, and surrounding coma. Hubble's observations complement those of JUICE by providing a slightly higher resolution view and allowing astronomers to compare images from 2 different vantage points within the solar system. By combining these observations, researchers hope to refine models of the comet's orbit, rotation, and potential variability in activity as it moves closer to the Sun. Since its discovery on July 1, 2025, 3I/Atlas has continued to intrigue both scientists and the general public. Classified as an interstellar object, it is one of the few comets identified as originating from outside our solar system, making it an extraordinary subject for study. Interstellar comets are particularly valuable because they carry material that has not been influenced by the Sun's radiation or gravitational effects over billions of years, potentially preserving chemical signatures from their home star systems. This allows scientists to gain insight into the processes that govern planet and comet formation elsewhere in the galaxy, offering a rare opportunity to study truly alien material up close. Each new observation provides a small but critical piece of the puzzle, helping researchers understand not only 3I/Atlas itself, but also the broader population of interstellar objects that may occasionally traverse our cosmic neighborhood. amateur astronomers and professional observatories alike have been actively tracking 3I/Atlas, capturing photographs and spectra that reveal glimpses of its composition and behavior. Despite the excitement generated by these efforts, even leading space agencies have struggled to obtain exceptionally clear images, highlighting the challenges of observing a small, fast-moving object from vast distances. Nevertheless, the data collected so far has already offered important clues about the comet's chemical makeup, revealing the presence of gases such as carbon monoxide and water vapor, as well as dust particles that may contain complex organic molecules. These findings contribute to the broader understanding of cometary chemistry, both within our solar system and beyond, and may even offer hints about the potential for life-bearing compounds to exist in other star systems. The scientific community is particularly focused on understanding the unique trajectory of 3I/Atlas, which differs significantly from that of comets originating within our solar system. Unlike typical solar system comets, whose orbits are influenced primarily by the gravitational pull of the Sun and planets, interstellar comets like 3I/Atlas approach the Sun from hyperbolic trajectories, indicating that they were not gravitationally bound to our solar system prior to their encounter. Tracking these paths requires precise measurements of the comet's position over time, as well as observations of any non-gravitational forces acting on the comet, such as the outgassing of volatile materials. By analyzing these factors, astronomers can determine not only the comet's past trajectory, but also predict its future path as it exits the solar system, potentially identifying its point of origin in another star system. In addition to its scientific significance, 3I/Atlas has captured the imagination of the public worldwide. Social media platforms and astronomy forums are filled with discussions, sketches, and photographs of the comet, reflecting the excitement that arises whenever a rare celestial visitor approaches Earth. This widespread fascination also underscores the value of public engagement in science, as amateur observations can complement professional data and provide additional coverage, particularly during periods when space-based instruments cannot observe the comet continuously. The collaboration between professional and amateur astronomers has historically proven fruitful in expanding our understanding of transient celestial events, and 3I/Atlas is no exception. As December 19th approaches, when the comet will make its closest pass to Earth, scientists are preparing for a flurry of observational campaigns across multiple wavelengths, from visible light to infrared and radio. These efforts aim to capture the most comprehensive data set possible, providing insights into the comet's size, composition, rotation, and activity levels. The anticipation is heightened by the possibility of detecting unexpected behavior, such as outbursts of gas and dust or changes in the comet's trajectory caused by interactions with the solar wind. Any such anomalies would offer additional opportunities to study the physics of interstellar comets in real time, advancing our knowledge of these rare visitors. In conclusion, while the newly released images from NASA's Hubble and ESA's JUICE missions may not be the sharpest or most detailed, they are nonetheless invaluable in the ongoing study of 3I/Atlas. The comet continues to challenge scientists with its unusual properties and interstellar origins, prompting close observation from professional observatories and dedicated amateur astronomers alike. As the comet approaches its closest flyby, every snapshot, spectrum, and measurement contributes to a growing understanding of an object that has traveled vast distances across the galaxy to visit our solar system. By combining observations from multiple instruments and perspectives, researchers hope to unravel the mysteries of 3I/Atlas, shedding light not only on the nature of this particular comet, but also on the broader phenomena of interstellar objects that occasionally enter our cosmic neighborhood. For now, the world watches with anticipation, awaiting further revelations from both space agencies and the dedicated astronomers who continue to track this extraordinary visitor from the stars.